Hello, my name is Beth Hewitt. I'm Marketing Manager at Yellow Dog, and this video series is going to be a conversation between myself and Niall Kennedy, our Product Manager, about all things that are happening in the cloud industry. Market trends, things we think companies should look out for, high performance computing and how that's migrating to the cloud, as well as things that we're doing here at Yellow Dog. All of these videos will be available on our website, as well as our social media channels. And if you have any questions or you'd like to get in contact with us, please feel free to. We'd love to hear from you. So, without further ado. Hello, and welcome to the first in our video series where Niall and I will discuss different things that are happening in the cloud industry. So today we'll be kicking off with an introduction into high performance computing, or HPC. But before we do, Niall, do you want to give a little introduction of yourself?
Sure, and great to be here. So my name is Niall Kennedy. I'm a product manager at Yellow Dog. I've been with Yellow Dog since 2018. My background is in product management in financial services, working with large investment banks and large corporates, particularly around the areas of foreign exchange and risk management.
Great. Okay, so let's start off with an easy question. What is HPC, high performance computing?
High performance computing. So high performance computing really is all about getting various kind of compute resources, bringing them together to get workload done effectively. And I would break it down into two kind of main areas, at least from the way that we would look at it from a Yellow Dog perspective. You have workloads that are what we call embarrassingly parallel. So each of the individual tasks are can be run independently. They're atomic, they're recoverable, and you can set up massive HPC clusters that can crunch through that. And then you've got the another type of use of HPC, which is all about using MPI. So in this case, rather than thinking of machines, we're actually thinking of a CPU and combining CPU together across a multitude of machines, again, to get work done.
Okay, cool. And who typically uses this type of technology?
It kind of varies. If you look at the history of HPC, it comes from the supercomputing kind of world where supercomputers are built and housed in massive complexes, and so given the expense of those things, they tended to be starting with kind of government agencies, academia, and some very, very large corporations who would have had the wealth behind them to actually get into the using supercompute. But what has essentially happened over the years is that as the ability to plug and play different components from different manufacturers, you start to see HPC being more widely adopted. It's used quite extensively in things like meteorology, in life sciences, financial services, aircraft design, car design, and so forth. So there's a lot of people now using HPC. And I think also, the term HPC, sometimes can be associated with, very, very large grids, but we're hearing a lot of new startups are looking for clusters to get their workloads done, which, ultimately does look like a HPC cluster for all intents and purposes.
Okay, and what about the future for HPC? How do you think people's expectations are changing, maybe in response to the pandemic or just the way that the trends are going in the cloud industry? What do you think is going to happen next?
Well, one of the key kind of movements is, cloud is here, and of course, cloud has been a lifeline for a lot of companies, and including us today, working remotely to use cloud to do things like this, to do Zoom chats, but also to house data and so forth. And there is a movement, and it's already started to take those HPC workloads that were normally on premise and put them in the cloud. And there are a couple of considerations there that people need to take into account. I think one of the big ones is the fact that you were previously working on HPC clusters that were very, were always on. They were a fixed size. You had a fixed set of compute that was part of that cluster. And now, as people move to the cloud, there are different things to overcome. In particular, how do you make use of HPC in the cloud in a cost-effective way? Making sure that the clusters you're bringing up are appropriate for the workloads you want to use. And there's other things as well around things like asynchronicity, heterogeneity. So asynchronicity is, for example, how do I know if I'm using multiple different types of machine, or even multiple providers? When I'm getting status updates, I might get them from one machine at one moment and another machine at another moment. Heterogeneity, I'm looking at different types of machines with different types of specifications, and what is the best workload, what is the best compute for my workload is really where people's kind of expectations are going to go, because previously, as I was saying, these were fixed grids, and this is not going to be the case in the cloud as much as people would like. There are going to be issues at times with availability, and those workloads, the best intentions would be to make those workloads a lot more flexible.
Okay, brilliant. So thanks for giving us that little introduction. It seems really interesting, and definitely a lot more topics that we can cover in future videos. So yeah, thanks for talking to me, and I hope that everyone found this interesting. Do keep an eye on our social channels for the future videos that we'll be releasing. So yeah, thanks, Niall.
No problem.